All right, they started the clock, so I better get going here. I have to talk about an 18-year-old mission in 15 minutes, and I get a little excited and a little bit rambunctious, so I'm glad they have a clock over there to keep me honest. Also, what I'm showing is basically on the left is the Atlas launch vehicle that we went up on. I'm Kurtis Thome, the project scientist for Terra. The launch in the very bottom here, we've got our nice logo. And just to put it into perspective is we were one of the first ones that started off these collection of satellites that are going around and around. Landsat 7 launched shortly before we did in April of 1999. We launched in December of 1999. We will be 18 years old next week. So come back in 2 more years. I'm sure there's going to be a grand 20th anniversary party here at AGU for Terra because it always coincides with AGU. So next. If you're not familiar with Terra, I've got a nice kind of summary of everything in terms of the numbers. 17 plus, I knew I was going to be here a few days before the 18th, so I couldn't quite put up the 18 years yet. 90,000 orbits so far. We have 5 instruments. We are Aster, Ceres, Modus, Miser, and Moppet. And what I like to tell people is they say, well, why isn't NASA doing constellations? And I say, well, we did constellations, we just did them all on the same platform. There was already doing this back in the late 1990s. We're 3 different countries. It's a nice collaborative effort between the Canadians, the Japanese, and the US. And that is where we get our 5 instruments operating that way. It's been a great collaboration. The title of my talk, if you notice, was basically Terra, a team effort. It's a multinational team effort, international. It's multi-instrument. So it's a lot of things that have to come together in terms of trying to get the data. We have a near real-time and real-time data sets. We have over 240 ground stations that are collecting data from Terra and basically putting it right back out, and they receive it straight from the platform. Downloads, 645 million downloads in terms of data sets to users. 280,000 journals around the globe are citing in articles. So we have 280,000 articles, 15,000 publications. The one I love to always point out is we now exceed Hubble in terms of number of publications. Well, of course, we have our 5 instruments, our 3 countries, and then all of the scientists that are taking the data. And then 83 data products. And that's really been the whole key to the Terra mission is these 83 data products. So a while back, we went through and said, you know, if we were going to break up our 83 data products into basically land, water, energy, and atmosphere, because that's basically the emphasis that we're using for the Terra mission and a lot of the Earth-observing science missions. And we broke them down in terms of, you know, all of the 17 years that we had, plus our 83 data products, break them up into the different sections, and then make the circle the size of the number of data products. And you can guess that I was pretty happy as the Terra project scientist when land ended up being the largest circle. I did not really want to change the name Terra to Aqua, so it was really good that land was our dominant thing because Terra's land. But we do have a lot of information still in terms of water, as you saw in the previous talk, is we're supplying some of the data that's being used by the ocean community. Atmospheres, clouds, aerosols, and so forth. And then the energy climate budget, the Ceres instrument is a very key player in terms of doing that energy budget. Next. Worldwide data users. This is now for the Moppet instrument because it's a little difficult for us to get all of this information for all of the different instruments. But the Moppet team, they recently had a review of their project, and they went through the difficult task of trying to track down where everybody was located and who's using what. And in terms of 266 total institutions across 41 different countries. And you can see how it's distributed. There's a lot of users in the United States. We work with, the Canadians are working with the UCAR-NCAR group in terms of distributing and processing the Moppet data. So clearly there's a large use in the United States. And then, of course, in Europe. But we have global coverage, and it's very similar across all of the instruments, all of the data products that we have. We have a lot of users across the world that are using these data. And what's really a nice thing about the Moppet, it isn't shown here, is it's a good example of the number of users has just been increasing over time. And it's pretty impressive to have an 18-year-old mission where everybody is basically still recognizing that we're producing results that are excellent and they want more of it. Because it's not like it's a competition, but we're starting to see people from the afternoon orbit, the Aqua users are starting to use the JPSS platform data that just launched a few weeks ago along with the SNPP platform. And so there's a lot of other places users can go for data, and we always want to make sure they know that Terra is still there. Next. And the question becomes is, what do you use Terra for? And we've animated this in the past, but it's also good to see it in one nice grouping. These are from the Aster instrument. And the Aster instrument, if you know Landsat, it's very similar to that. It's a multispectral thermal instrument. It's a high-resolution visible near-infrared. So these data are from basically a green, red, and near-infrared wavelengths at 15-meter spatial resolution. It's the wonderful area around Dubai. And these are one of the obvious types of cases where if you have an 18-year record, you start going, well, let's start looking at change over time. You can look at change over different parts of the globe. But in this case, if you look at starting point in the upper left, working your way across to what it looks like in the lower right, and it's not as easy to rely on the rest of the planet to basically assume that everybody's going to start building islands. But it's a good, nice visual example, really quick, that we can find subtle changes in addition to these really big, obvious changes that are out there. Next. And when you start looking at change over time, now you can start doing a nice thing about Terra is we're a satellite, so we don't have to just look at a small region of Saudi Arabia area and in the Persian Gulf. We can do global coverage. And in this case, we're looking at data from the MODIS instrument, net primary productivity. The previous speaker talked about it's looking at how the Earth is breathing. And you can kind of look at it in terms of where it's green is where you're starting to see increase in productivity due to primarily vegetation. Where it's red is regions where you're starting to see a loss over that time period relative to other things. And the whole time series, it's going from basically launch through, in this case, it's a 15-year cycle. And you can start to see things changing both in terms of on an annual scale, seasonal scale, but then from year to year, you start to look at what's happening in terms of where we're starting to see deforestation, where we're seeing increases in vegetation use, and where we're starting to see other effects in terms of population movement and so forth. And making sure that you have a set of instruments that are well calibrated and agree with each other, both in our case with Terra and Aqua, we have the MODIS instrument on both of those platforms, but also between the different instruments on the platform, we have to ensure that we're getting a lot of communication between those different instruments. Next. The series instrument, as I mentioned, is doing our radiation budget. So this is net radiation on a monthly scale. The reds means there's more energy coming out of the Earth atmosphere system, and you basically can start to see what's happening over time, again, in terms of monthly from 2006 to 2013. And I'm not going to try and say, you know, here's the conclusion you should draw from it, but it's basically, series is a good example of you have data from the Terra platform, it has data from SNPP, data from the Aqua platform, multiple other data sets are coming in for series that they combine together to create something like this in terms of understanding what the monthly net radiation is doing. And you primarily are seeing the seasonal shifts with time. But then the series team is able to tease out little, small, tiny effects that have been happening over these decades because they have these long, nearly 20-year of records to try to understand, especially when they combine them with the IRB data and the ERB data from going back in time, to see what's happening from these small little of shifts in net radiation. Next. Aerosol optical thickness. So I'm going back to MODIS, and what you're looking at is in the places that are black and missing is either there wasn't any sunlight to give us data, or there were clouds, or there was a data set that we could not understand. We could not tell the difference between a cloud and whether it was dust, and so it gets omitted. But you're able to see biomass burning over the Saharan desert, plus the dust storms coming off the Saharan. In the United States, you can start to see some of the pollution areas where you get increases in aerosol amounts. The reason I start with this is, one, again, we have this long-term history, but then on the next chart, I point out that we're combining data from MODIS, and we combine it with MISR, and we now are able to start understanding, and what's showing here is satellite-derived PM 2.5. It's particulate matter of a certain size. Basically, where you see reds, there's a lot of particulate matter, which is not good. But we're getting this particular result by combining the results from MODIS and MISR from the same platform using different measurement techniques. MODIS is a wide swath system, gets a lot of daily coverage. MISR is a multi-angle look system, which is very unique and only on the Terra platform. And the MISR information combines with the MODIS information, and now we're at a point where we're starting to understand that where the largest populations are most affected in terms of particulate matter. And so that's a great conclusion that we've been able to get from the Terra data set. Next. Combining data even more, and this one I love is because I can show results from pretty much all of the instruments at one time, and it's the wildfires. And this is something that's really taken off in terms of the MODIS team started using data to prove out that we could do wildfires. VIIRS is doing similar things, and where you can see the wildfires is obviously all of the red dots, and the more intense as they start to go to yellow. But we're combining that with, say, MOPIT, because MOPIT is looking at carbon monoxide. And we're starting to find that the fires are enormous sources of carbon monoxide. So now we can start getting an idea of the size of the fires based on the amount of carbon monoxide. We can pair up the data with MISR because of the multi-look angle information to get a better idea of what the altitude of the plumes are. And the plumes give us an idea of the heat from the fires as well. ASTER allows us to zoom in and start looking at the regions in terms of burn scars, and also if we get the right timing, we can give information to the firefighters on the ground where they should put their assets. And then in terms of Ceres, we now have an idea of what's happening with the ground underneath all of the measurements that Ceres is making to try and help us understand better the radiation budget that goes along with it. It's the perfect example of the Terra team in terms of the 5 instruments working together to give us the best information that we can. And it all assumes that we have the right amount of information related to the calibration of the instruments. Next. And that's where this is the last one. So my background is calibration. And so I kind of really love this. And the science, it says Terra flips for science. Think about now you have an 18-year-old mission that's been looking at the Earth except for one small month in 2003, and you're trying to get results of wildfires and aerosols and Earth radiation budget, and then you decide that you want to go ahead and flip it over and go ahead and look at the moon, because the moon can be used as a standard lamp, and that can allow you to find out if your instruments have changed over time. You can tell that there aren't a lot of people that are going to be real excited about you doing this. So now you have to work with the team that's running the platform. And so we had to work with our group in the Mission Operations Center for them to plan this out. And they had to then convince the people at NASA headquarters that what they were going to do was safe. We had to get all of the instruments talking to each other to make sure that we were not going to upset the operation of any of the instruments, so that when we had data from MODIS, MISR, and ASTER, that we end up with a well-calibrated set of imagers, but at the same time not harming the other instruments. And so I like this because, one, if it had gone wrong, I would have been blamed, which I'm willing to do. Two, it was really exciting for me because I was the one who took this photograph. If you've never had a chance to be in the operations center of a satellite, and you've probably seen some of the movies where they go down the list of, flight, go, science, go. Being the guy who says go is really kind of fun. At the same time, it's a little bit scary. And so we were pretty excited. We're getting really good results from this already in terms of looking at the 2003 and 2017. That's ASTER, and we're seeing already the preliminary results that are giving us an idea of the calibration of the instruments that will allow us to still continue to operate as a team, basically a constellation on one platform, to get the most science with the best quality results from things like this. So, thank you.